So first and foremost, you're going to need a good quality soldering station. Now, many of you might know there are two types of soldering device in general that you'll commonly use, and people sort of mix up and interchange the terms for it. A lot of people will say it's a soldering iron. It's not. What you want is a soldering station, one of these. And this is actually a fairly cheap soldering station. I think this was about 25 or 30 pounds off of AliExpress. It's a KSG T12 soldering station. Now these are compatible with Hakko soldering tips, commonly known these days as T15 tips, but the cheap tips, the T12 chips, which are manufactured in China, are exactly the same thing. They're cheap, they're cheerful, they get the job done. But anyway, so the difference between a cheap soldering station and a cheap soldering iron is quite large. So, for example, a soldering iron, the type that you might get for about 10 UK pounds, $10, somewhere like Harbour Freight or B&Q if you're British. They generally work using a heated ceramic core, and a heated ceramic core will heat a small piece of metal, which is the soldering iron tip, until it reaches the maximum temperature that the iron's capable of reaching. And there's no temperature control on that, and that temperature could really well be anything. Who knows? Just whatever that iron can put out. So we tend to try and avoid those kind of irons because they're not particularly great. So as I say, soldering station, that's the way to go. These have temperature control. They will directly heat the tip itself at the very end. So this part won't get hot. It'll be warmish around here, warmish around here. You'll be able to hold it like this while it's switched on. Further down you'll burn yourself because all of the heat is in this bottom part of the soldering tip. So yeah, these are absolutely fantastic, and for the extra $10–15 that this is going to cost you over a traditional soldering iron, just get one of these. Don't bother with a regular soldering iron. They're a waste of time, they're a waste of money, and you're actually more likely to do damage to things that you might be soldering than you would be with one of these, because again, you can control temperature. So we'll get this out of the way. When it comes to soldering, it's good to have a selection of different soldering iron tips. Now each of these is quite cheap. One of these tips, for example this one, they're about £2.99, £3.99, something like that. You can get these off of AliExpress, you can get them off of eBay and potentially Amazon. Links in the description down below. And it's just good to have a selection of these. Now, the tips that I particularly like, personally, are the BC1, BC2, BC3, and I sometimes use this one as well, but I forget what this is. JO2, I think. The J-series tips. And J-series tips are just curved. So if you look at the end here, you can see that this has a curved tip. These are for micro soldering. So you really want to use these when you're working on tiny little components on tiny little PCBs. That's out of scope for this video, but it's just so you know. And again, there are absolutely all kinds of crazy soldering tips that are used in different scenarios. And there we go. So that's sort of soldering tips covered. Other things you're going to need. Soldering wire. This is quite important. This particular one is Kester, manufactured in the United States. This stuff is great, absolutely fantastic solder. It'll last years and years and years. And this particular one, I believe this is an RMA, no clean solder. This is a tin lead alloy. So 63 tin, 37% lead, and it's 0.8 millimeters. I actually use this quite a lot for all kinds of different soldering. The diameter is a good size, and this wire is just, you know, it's just a really good solder. It's expensive, but it will last you a very long time. Now, there is another type of solder that you can use. I should have a spool of that just here. This is tin silver copper, which is more commonly known as lead-free solder. A lot of electronics repair technicians don't like using this stuff because this stuff it's a little harder to work with, and it's not eutectic like like leaded solder. Leaded solder has a melting temperature, a sort of flash point. So once you hit that very specific temperature, it will melt. These solders have a melting range. They're not eutectic. So they'll melt both at a higher temperature and at a sort of variable range as well. So there's no flash point. It will just transition to a molten state in a particular temperature range. So it's a little harder to work with. It's also not really as good in terms of reliability for solder joints. It will make good solder joints and they will last, but leaded solder is generally more reliable to use in this stuff. Also, it should be noted that you shouldn't really mix solder chemistries, so you shouldn't mix a leaded solder with a lead-free solder, because you're going to get a different alloy that forms from that with different characteristics, and it may well be unreliable. So if you are doing any kind of soldering, stick to one type. Either use leaded or use this stuff. And again, as I say, this stuff has its uses. It's certainly less damaging to the environment and people than leaded solder. Not that there's a huge risk with leaded solder, but I'll cover that now. So, leaded solder, as the name would suggest, contains lead. Now, lead is a neurotoxin, and it's bioaccumulative. And what does that mean? Well, that means that with each subsequent exposure to lead, particularly any kind of exposure that might enter your body, so we're talking potentially lead fumes coming off of the molten solder, which is less likely actually. You're more likely to damage yourself with the flux that's contained within the solder, which is usually rosin or an RMA flux. But again, there are other exposures touching the lead, touching the solder. For example, over time will leave you exposed. You will leach a very small amount of that lead into your body. Now, as I say, it's bioaccumulative, and what that means is each subsequent exposure adds on to the exposure you've already had. So it never leaves your body. It's permanent. Once it's in your body, it's in your body. Using it once or twice in your lifetime is probably not going to be an issue, but it should be noted that there are no safe limits to exposure to lead, and that's one of the reasons it was actually phased out of use in the first place. Prior to the year 2000, most things used this leaded solder, again because it tended to produce more reliable joints, it was easier to work with, and so on and so on. There's a lot of benefits to using leaded solder. But the downsides are the worries around e-waste. So as you can imagine, billions of devices, take for example mobile phones. People switch out their mobile phone maybe every couple of years on average if you're a typical phone user. Now if you're doing that all the time, every few years, where does that phone end up? Well, some of it gets resold on the second-hand market. That's fine, it's still being used. Happy days. But unfortunately, a lot of it ends up in e-waste landfill. As you can imagine, billions of devices in gigantic landfill areas. That's a lot of lead that's going to accumulate over time in one particular area. And what that would mean is, over time, as it's exposed to the elements, as the plastics degrade, as the device falls apart and disintegrates, not only is that releasing a whole bunch of nasty microplastics and other nastiness that we won't cover, that lead is actually slowly seeping out and contaminating the environment around it. So, you know, you can imagine if you've got several thousand tons of this stuff in one area and then it's raining all the time and so on, you're going to get small amounts of lead leaching into the water table, and that became an environmental concern. And in the year 2000 it was decided globally to phase out leaded solder during manufacture of electronic goods in favor of lead-free solders, of which there are various types. It was the right move, it's still the right move, but unfortunately it is not the most reliable, and there are issues around that in terms of reliability and so on. Now you can imagine at a small scale, any kind of repair shop, we're talking high street repair shops for mobile phones, laptops, games consoles, whatever that kind of electronic device is fine, because the volume of that is significantly lower. So you may have a very small amount of lead in each device, And it's just much less of a risk because we're not talking, you know, billions of devices. We're probably talking globally, maybe hundreds of thousands, potentially millions of repairs, and using very, very tiny amounts of solder. Now, as I mentioned a moment ago, this stuff will last forever because you don't use much. So we're talking, you know, maybe like a few grams, the tiniest amounts of leaded solder that you will use in your general soldering life, repair life. So that covers solder, why we use the different types, what their usage is, and so on, so on. Now, other tools that are handy to have. It's always handy to have one of these, and this is just a simple, cheap desoldering pump. I actually don't use this. I have more professional grade equipment. You'll need this. This is a Flux. This is RMA 218, made by Kingful Total Distribution. This is a Chinese-made flux for soldering, and this stuff is actually really, really good flux. People talk about using the more expensive fluxes, but there's honestly not much reason. A tube of this is going to cost you about $3, around about £2, something in that region. Quite cheap. You'll use it all the time, pays for itself, and makes everything easier. Now, you may be asking, well, what do I need a flux for? So, when soldering, what happens is oxides form upon the components that you are soldering. So we're talking, and on the solder itself, which is the biggest issue. And what that means is basically it's a layer of crusty, rust-like substance, and it causes bad solder joints. Now, these fluxes are slightly acidic, so as you heat it up on a solder joint, it will eat away at the oxides that are forming, and it will keep the joint nice and shiny and wet, and that it means you will get good solder joints. If you don't use this, eventually whatever flux is contained within your solder wire, which most solder wires have, they have a cord in a container sort of thing of flux, and I'll slice this open under the microscope in a little bit to show you that. But the point is, this will make your soldering life much, much easier, and you can't really do any serious soldering without this stuff. You can do quick solder joints with the flux that's in the wire, but if you take too long and you apply too much heat and you burn away the flux that's contained within that solder wire, you're going to get absolutely terrible joints. So there we go, this is important stuff. Now, the next thing you're going to need is a way to clean this stuff off. Now, what we have here is a nondescript bottle full of what looks like Russian vodka. It is not Russian vodka. This is 99% isopropyl alcohol. I think it's 99.9% actually. This stuff is a solvent, and it's incredibly useful for electronics repair and soldering in general. It's absolutely fantastic for cleaning up areas that have dirt on them, on the boards, on wires, on whatever it is. But the other thing is, as I mentioned, it's a solvent, which means that it will dissolve the flux that you might be using, such as this one. And so, as you get crusty flux building up on your board, you just squirt a little bit of this on, then use the next thing that should be in your arsenal, which are cotton buds, cotton swabs, or if you're in America, Q-tips. It's always good to have these in your arsenal. Now next, wire snips, flush cuts. These are very cheap, Plato Model 170 pliers. If you watch electronics repair videos on YouTube, you will see a lot of people using these. They're very cheap. They are actually quite good flush cuts. And did I mention they're very cheap? You know, doesn't have to be these Plato ones. I use these. Now you'll also need some good quality tweezers. These are very, very fine, precise tweezers, and they're also extremely cheap. These cost around about 70 to 80 pence off of AliExpress. And the reason you're going to need a good pair of tweezers whenever you're doing any basic soldering is so that you can hold components which are going to be extremely hot, as you've got a hot soldering iron tip on there, and allow you to hold it in position without burning your hand off. Now next is some kind of blade. I particularly love this blade. This is a Scalpel. It's Swan Morton. It comes with removable blades, and these are curved, as you may notice right here. Now that curve is particularly useful and handy for scraping away at things. So if you've got some solder mask on a board, on a printed circuit board, it's really good for scraping away. And not only that, but it's so sharp because it's a scalpel. And that means you can cut into things that you might need to cut away. You can use it to strip insulation off of wires, all sorts. These things are just, you know, an absolute essential in anybody's toolbox. And the blades are extremely cheap. You can buy those separately. So they're handy to have. Now next, this is incredibly important, is a good desoldering wick, desolder braid. I absolutely love this stuff. This is Chem Wick. It comes infused with rosin flux. So when you use it, you'll get a kind of brownish crud coming off of it, but that is doing a really good job of like breaking down any oxides on a board when you're desoldering any kind of solder or something like that. It's not just used on printed circuit boards. You can use it on anything that has any kind of solder joint. And what will happen is you place this on top of your solder joint, you come in with your soldering iron on top with a good bit of heat, and that heat will then heat up the desoldering wick and transfer into the solder and the joint using capillary action. The general gist is it will soak up like a sponge any solder and draw it into the wick. Now you probably shouldn't leave it on a huge strand like this, because if you do that, the heat will radiate down and away from your joint. So what a lot of electronics repair technicians will do is cut off a small amount and use that. But it depends on your situation and what you're doing with it and where you're using it. But you absolutely must have some of this if you're doing any kind of electronics work. Highly, highly recommend it. Definitely incredibly important is one of these. Now this is a brass cleaning ball used for cleaning your solder tip. Now you can buy these pretty much anywhere that sells soldering equipment. Traditionally people used to use sponges to clean soldering tips, but these are just so much better. They'll last absolutely ages, and they'll take all of the oxides that are formed on your soldering tip and just strip it right off. They're absolutely fantastic. Something else which is handy to have, not required. This is a block of what is essentially pure bismuth. You can use this as low melt solder. When this stuff mixes with tin and lead, it forms an alloy that melts at an extremely low temperature. So we're talking like somewhere in the range of 80 degrees Celsius is where that solder will melt when mixed with this. This actually melts at a much higher temperature than that, but once it's mixed in with tin and lead, that melting temperature will then suddenly drop, and you can use this in areas of electronics rework that require a low melting temperature. That might be things like HDMI ports on game consoles or anything like that. You don't need it, you don't necessarily have to have it, but it's handy to have. What I cannot overstate is having a solder fume extractor. This is a Cotto. It's relatively affordable. It's a mid-range fume extractor. You can buy them off of Amazon. Don't cheap out on this. Get one of these. You can direct this hose, put it near where whatever you're desoldering or soldering or whatever it is that you're doing, whatever work you're doing, switch it on, extract the fumes away. You must have one of these. Don't cheap out on it. I did cheap out on this initially, and I used to use one of these, an FA400. Many of you may have seen these and opted to buy these yourself. They're crap. Don't use them. Don't bother. They're just a general roundabout way of absorbing fumes. They will create a little bit of airflow, but you'll get a lot of leakage into the surrounding area with one of these. You get what you pay for. These cost next to nothing, and they're just not worth it. Get yourself a Cotto, or get yourself any equivalent fume extractor like that. But don't cheap out. You don't want to be inhaling flux fumes, because flux fumes are incredibly harmful, and I believe they may even be carcinogenic. So you absolutely don't want to be inhaling that. Cannot stress enough, get a fume extractor and use it regularly. Just for the sake of this video, I thought I would bring in a cheaper digital multimeter. This is as cheap can get. I would not recommend one of these. It's not auto ranging, so you have to select the settings manually. It doesn't even beep for continuity, which is kind of annoying, particularly if you're looking at something under a microscope or whatever. So recommend against these, but if you're just starting out and you don't plan to do any serious repair and you just want to use it to check to see that you've done something correctly, this is fine. This is absolutely fine. So let's say we want to check voltage. I set that to 20 volts. You select the range dependent on what you're working on. So 20 volts in this instance is going to be fine for checking something like this Duracell Power battery. And to check it, you simply take the two probes and you put the COM negative on the negative terminal, the positive on the positive of the battery, and you'll notice that we can see we've got 1.48 volts there. Now, if you wanted to do a continuity check, for example, between 2 points to see that we've got continuity through a circuit, you'd put it into resistance mode. In this case, I've put it into the 200 ohm range, which should give us anywhere from 0 right the way up to 200 ohms, which is low on the resistance scale. The lower the number, the more well, the less resistance there is in the circuit. The lower that number is, when you touch the probes together, for example, will indicate whether there is continuity. So if I press these two terminal leads together, these two probe leads together, we should see something in the range of maybe 0.05, something like that. Let's have a look. Close, 0.2. So we can see that we have continuity there. There is no beep. But if your multimeter doesn't have that functionality, if it has resistance, you can at least see it on there. This thing will also measure capacitance up to 2000 microfarads apparently. I'm not sure I believe these numbers much, but there we go. Quite basic. Resistance, voltage, AC, I think that's for measuring things like transistors, diode mode, which is quite handy as well. This multimeter would not be particularly great for anything serious, but again, if you're just starting out, cheap multimeter like this will do the job. So, as just mentioned, solders have flux within them. Flux is incredibly important to the soldering process. This is Kester No Clean, which will contain a no clean flux. Some solder wires contain rosin flux. And rosin is slightly corrosive. If you leave that on a board, it can potentially cause corrosion damage, so it's always smart to clean it up. But in this case, what we have here is a piece of Kester No Clean. But if we cut into it, like this maybe, we can see there's a little channel with flux in it. Right there. If we zoom in a bit, we can see, if we take a pair of tweezers to it, that we can scrape the flux out. And there we go, we've got flux right there on the end of the tweezers. That flux prevents corrosion from occurring when soldering. Now, I can demonstrate what happens when there is no flux in your solder, and we can simulate that quite easily. What we'll do is we shall heat the solder until we've burned off some flux. So what I'm going to do that is activate my Fume extractor, incredibly important to have running. There we go. And we'll apply some solder to our iron like this. We've got a big old blob. You can see it's kind of burning up and it's going a bit iffy. And that iffiness is what happens when there is no flux to dissolve and break up the oxides that form. And if we just rub this over the pads, look at this. This is what happens. Look at this crusty... There. This is a very common mistake many people starting out make. I made this mistake, I'm sure many others have. That's what happens when there is no flux in use. Now, we'll go to this other line, and we will use some flux just below it. And again, you can see all that crusty, icky, not so greatness, but we'll just blob a bit of flux here. We'll come in again with the exact same type of solder, and we'll just run it across like that. Boom, boom, boom. A bit more. Fill in these holes. We can see that we've got some very, very shiny solder joints. Now, if, for example, this happens above, where you've got oxides formed on your solder, what you do, you come in with your flux, squirt a bit on there, get your soldering iron nice and hot and clean, rub your iron tip across, and look at that. Now it's pretty good. Now, I did mention that it's not a good idea to leave flux on the board. Now, this particular flux I'm using, RMA218 Kingbo, it's a rosin mildly active flux. Mildly active means that it does have a mild amount of acid which is responsible for eating away at oxides that form. So it's a good idea to get it off the board. It's not going to cause a big issue because it's no clean. But what we want to do is get it off anyway, because even though the flux itself may not cause any particular issue or damage, it is a kind of wet, pasty substance which can attract moisture, which in turn can actually cause corrosion. So we'll come in with our isopropyl alcohol and we'll just rub around with a Q-tip, cotton swab, whatever you want to call them. We'll just clean up like this, and it will remove the burnt flux in the area and get the board looking nice and clean. And you should do this. You should always do this, just because it's better to clean it up. And there we go. As we can see, we've got a cleanish board. I think I've got a fibre there. But there we go. So what we have here on the screen is a printed circuit board with a very simple connector, and what I'll demonstrate is how to solder that. Now, there's a couple of ways. You can apply flux, or you can go without flux and just use straight solder wire like we can see right here. So, we will take our soldering iron, clean it, get a nice shiny clean tip, come in with the solder, and what we'll do is heat both the pad and the leg of one of these at the same time. Come in from the opposite side and just feed the solder in, and as this gets hot enough we'll see that it will melt, and there we go, that's melting, and there we go, that's a solder joint. Now that's a little bit too much solder on that, but that's okay, we can fix that. So that's one soldered. Now we'll do another one, same thing again. We'll heat both the pad and the leg. There we go, and that's a little, like, not enough solder. So too much solder, not enough solder. And then we'll take this pad right here on the end, and that's just about enough solder right there. And what we'll do is this one here, we will make a pour joint. So to do that, I'll simply apply solder, and we'll leave the heat on until the flux is burned off and we get some oxidation on it. So that's probably long enough for that, and it's not looking so great. And there we go. So The first one that has too much solder on it is this one. We can see that there is quite a lot of solder on that. To fix that, we can take a little bit of desoldering braid, as I mentioned earlier in the very introduction, and we can desolder some of this. So we just apply heat to the wick, and just like that we've removed the solder. You can see most of it's gone. There's still some solder on there, but that's okay. But that allows us to now retry that joint. So if we retry this joint now, so again, same thing, and then we just, boop, and that's a much better joint right there. We can see it's a sort of nice round mound, and we can see the other one next to it's not got enough solder, so we'll apply some solder to that to fix that issue. And so to fix that, clean our soldering iron and just come in and just add a tiny bit more solder. Boof, boof, there we go. It's a nice clean joint now. And then we'll look at that other one that we burned up, and we can see that the surface of the one that's a bit burned up, which is this one here, it looks a bit bumpy. If we zoom in on that, you can probably see what I mean. It's shiny, but it's not how we want that to look. So what we can do to fix that is add flux, which is ever useful stuff to have in your toolkit. So we'll just go ahead, squirt a little bit out of the end. Doesn't have to be much. That's more than enough. And then we'll tap it with our iron to melt the joint, wiggle it around a bit, done. Now that's a much shinier joint now. We will add a bit more solder though, because it's a little bit flat. So there we go. And then we'll add a little bit more to this one. There we go. Now, one of my favourite soldering tricks is to drag solder, and I'm going to demonstrate that here, and it may actually bridge some of these connections together. If it does, not to worry. But what we do is we come in with our iron again, add a whole bunch of solder to the tip, like this, and we'll just move along, just like that, move along. Let's see if we can get these to bridge. No, of course we can't. But this technique is called drag soldering. We can see I'm actually filling in a hole I don't want to. And that's where we can demonstrate more desoldering techniques. We just go along the line, and there we go. Now these joints look pretty bad. Particularly this joint here. This joint looks like a cold solder joint. It's kind of matted and bumpy looking. Let's see if we can get a better view of that. So if you see that, it looks matted, it looks bumpy, it looks quite bad, and that's what we call a cold solder joint. We can fix that with flux and heat. So what we'll do is get the flux again, blob a bunch of it down around here, like this, and like this. It should be more than enough. And we'll come in with a soldering iron and just heat it all up again. Using the same drag soldering technique, just like this. That's it, all those joints are now absolutely perfect. Now, as mentioned earlier in my video, you will get burnt flux, and we can see that here. You see this black gunge and scungy looking stuff? That's just burnt flux. This last one looks like it could do with a tiny bit of a touch-up, actually. There we go. And there we go. So we've got that soldered on pretty nicely. So, as is sort of a thing that occurs, we've got solder where we don't want it. So we've filled in this hole here, and we've sort of semi-filled in this hole here. So I can't push my tweezers all the way through that, and I definitely can't that. So these holes have too much solder in them. To fix that, we'll actually add a little bit more solder to the one that's not fully flush. And the reason we do that is to bring the solder up to the surface level of this via, which is what this component is called. Well, actually, this is a plated through hole. But we'll bring the solder level up a bit so that when we get the wick on, the wick can actually wick it up. So we'll just go ahead and apply... It's a bit wobbly. Apply some heat. Like this, add some solder, and fill the hole like that. Same with that one. And there we go. Now what we'll do is we'll come back in with some desoldering wick over the top, apply our soldering iron, and it will magically wick it away. And as we can see, those holes now are completely clear. So that's how you would remove excess solder that you don't want. And as you can see, I can push my tweezers through this hole now, and this one right here. So there we go. Now, you may notice there's a bunch of this nasty looking jellified flux everywhere, and to clean that up, what you'd do is you'd take a cotton swab, as mentioned earlier, and some isopropyl alcohol, and drip the isopropyl alcohol on the area, on the swab, and then rub it up and down like this. And you can see it's already removing some of that scungy, grungy mess. So we'll just rub up and down, rub up and down. You may lose some fibers from your cotton swab, but that's fine. We can remove those if need be. And we'll add more isopropyl alcohol on. You can't really use too much isopropyl alcohol on these. You're never going to damage it with IPA. And then we just rub more and more around the area. We're catching the fibers on the joints, but that's okay, because we want to get in between so that we get all of the flux up. Now, the reason that we remove the flux is largely not because it's going to damage the board leaving it on. It actually won't, but what it might do is attract moisture over time. And so by removing it, we remove a potential sponge source of moisture on the board from atmospheric moisture, and that way we just avoid the possibility of corrosion occurring in the future. And corrosion is the enemy of electronics. As we can see, I'm kind of struggling to get between these, but I can scrape that away if I want to. And looking at that, that looks pretty clean. Now you may notice there's a bit of burnt flux here. You can just break it up with your tweezers if you want to. Same here. Just very lightly nudge it. You don't have to do anything crazy to get it off. Or alternatively, what is useful in this scenario is a brush. So what we can do is add more isopropyl alcohol, take a brush like this, a little stiff bristled ESD brush or a toothbrush. Toothbrush is perfectly fine for this, and just rub over. Rubbity rub, just like so. And there we go, that's got most of that mess up. And of course, we still have a little bit of burnt flux just here, so we'll just rub that up and down with some tweezers to see if we can break it up a bit. because it seems to be baked on pretty hard. It is, but it's coming up just fine. So there we go. And as we can see, that's soldered on nicely. We've got very shiny, clean looking solder joints. And if we look at it from the side, you've got a little bit of glare and reflection there on those highly bright joints. Let's see if we can do something about the lighting. But that's what good solder joints look like. They're perfectly fine. Now if we flip the board, we can see we now have our connector header on there, looking nice and clean. I hope this video was interesting. I hope you learned something. And as always, until next time, bye for now.